Hi, my name is Frank Ham. I'm a Vice President at Cadence, leading our CFD solver development, and I'm excited to introduce the Millennium M1 CFD Supercomputer for high-fidelity computational fluid dynamics. Millennium M1 combines the best-in-class Fidelity Charles solver for large eddy simulation, or LES, with scalable, high-performance GPU hardware for unprecedented accuracy and speed. This powerful combination of hardware and software extends the practical application of LES in aerospace, automotive, and energy generation, reducing turnaround times from days to hours and revealing product performance insights as never before. But why do we need to run LES? Well, it's all about turbulence. CFD engineers must consider turbulence when designing cars, airplanes, jet engines, even sailboats, and various approaches are available for turbulence modeling in CFD. Reynolds average Navier-Stokes, or RANS, turbulence models are preferred for a wide range of applications because of their efficiency, but they are calibrated models, not based on first principles, and because of this, for certain cases, the RANS approach is not sufficiently accurate or predictive. In the large eddy simulation approach, the largest energy-containing scales of turbulence are simulated directly, evolving in time much like a real flow does. This can make the LES approach much more accurate and predictive for certain flows. Flows involving separation, transition, acoustics, or chemical reactions. But computing these time-accurate multiphysics flows can be extremely costly and time-consuming. These computing power limitations, more or less, have kept LES from becoming a broadly applicable solution. But with Millennium M1, that is all changing. 4 critical technology advances are lifting these limitations and extending the practical application of LES. And they are around automation, accuracy, acceleration, and AI. First, automation. Predictive high-fidelity simulations require high-quality meshes. By leveraging clipped Voronoi diagrams, mesh generation can be highly automated, massively parallel, and robust when processing the most complex geometries, creating high-quality production meshes within just minutes. Second, accuracy. The Fidelity Charles solver is purpose-built for large eddy simulation, using an accurate and stable low dissipation numerical method. This unique solver discretization is combined with the latest subgrid scale and wall modeling to deliver an LES capability with remarkable accuracy and robustness to grid resolution. Third, acceleration. Fidelity Charles is a GPU resident solver, fully leveraging GPU acceleration to provide cost-effective, high-throughput simulation. For a given investment in computing, the GPU solver achieves a remarkable 9 times increase in throughput relative to a CPU. And for a fixed simulation throughput, the reduction in energy requirement of GPU computing versus CPU computing is about 17 times. And fourth, AI. Traditional CFD simulations are either too inefficient or too inaccurate to generate the large datasets required to train modern AI models. With Millennium M1, it is now possible to automate the generation of large databases of high-fidelity simulations, train AI models efficiently on the same Millennium M1 hardware that the datasets were generated. And the same M1 hardware can be used to inference those models and replace some of the future simulations, further accelerating the design process for better insights and faster closure. Let's look at a few of the large eddy simulations now possible using Millennium M1. This simulation shows the shear stress on an aircraft wing complete with slats and flaps deployed in landing configuration. At high angle of attack, near peak lift, the Fidelity Charles solver correctly captures the flow as it starts to separate off the wing and stall. This simulation required about 14 hours on just 2 Millennium M1 nodes. This simulation shows the flow speed visualized on the center plane of the NASA Source Diagnostic Test, a turbofan designed by GE and NASA to validate the noise prediction capabilities of CFD for turbomachinery applications. Fidelity Charles accurately captures both the tonal and broadband components of the noise. This simulation required less than 7 hours on 2 Millennium M1 nodes. This simulation shows the temperature and other predicted quantities in the Energy Efficient Engine, or E3, an aviation engine designed and tested by GE and NASA in the 80s. This Fidelity Charles simulation includes liquid fuel injection and conjugate heat transfer to predict liner temperatures and required less than 8 hours on 2 Millennium nodes. To simplify the deployment process for our customers, Millennium M1 is available in 2 options: cloud and on-premise. Millennium M1 Cloud is hosted by Cadence and provides stackable compute nodes that scale with the application. General purpose and ITAR certified environments are available. Millennium M1 is also available as a turnkey solution installed on-premise within the customer IT infrastructure. We are ushering in a new era for high-fidelity CFD, unleashing new predictive capabilities, insight, and performance gains. Today's leading engineering organizations need a partner with expertise in computational software, innovative hardware, and AI. Cadence is uniquely positioned to be that agile partner and deliver next-generation solutions. This is just the beginning. The Millennium M1 Enterprise Multiphysics platform will continue to evolve to offer more of Cadence's multiphysics simulation portfolio. Join us on this journey to transform digital engineering. For more information, visit cadence.com.